Hi students, welcome to lesson on exercise 10. This is the trigonometric ratios. Okay, so now we're talking about the unit circle again. We're back there. So the radius is 1. So anytime the radius is 1 or you're on the unit circle, the arc length, right? The arc length around the circle, that's actually the angle in radians. Okay, so any arc length will be defined by pi over 6, pi over 3, all those ratios. And then the point at that arc length will be defined by x and y, so the point on the unit circle. Again, think back a unit circle that we've already drawn, all those points and those angles. That's basically what we're talking about. Alright, so if we were to use the trigonometric ratios sine, cos, tan, or SOHCAHTOA, which you've learned before. Okay, so I'm just going to draw a quick triangle on this thing here. So this is 1, okay? This is your y, and this is your x. Okay, so if this is your angle here, sine of your angle will be y over 1. So basically what you can do is you can basically say sine is y. Looking back at grade 11 pre-cal, that's why in quadrants 3 and 4, sine is negative, because y is negative. Okay, cos is adjacent over hypotenuse, and that means x over 1. So again, cos is x. And again, going back to the grade 11 pre-cal thing, here you're in the second or third quadrant, cos is negative because x is negative, right? So x is negative over here. And then tan is a ratio of sine and cos because you're doing opposite over adjacent, so y over x. And since sine is y and cos is x, you can also say tan is sine over cos. Okay, so that's one of the reasons we can say any point on the circle can be defined as cos of the angle and sine of the angle, because cos is the x and sine is the y. Alright, so we're going to learn some new functions today. The primary functions, which you already know, that's sine, cos, tan, and we've just defined them as y, x, and y over x. Okay, so there's reciprocal functions. The reciprocal functions is basically going 1 over sine x, or sine y, or sine theta, sorry. So 1 over sine theta, that is called cosecant, and CSC is the abbreviation. So cosecant theta is equal to 1 over sine theta, and another way to look at it, it would be 1 over y. So it's a reciprocal function. Okay, secant is the reciprocal function of cosecant, cosine, sorry. So secant is the reciprocal function of cosine, 1 over x, and cotangent is the reciprocal function of tan, so cos over sine or x over y. Okay, so again, these are all things that you should kind of remember, have them in your back pocket of memory. Alright, so in the first example, we've got a point that's on the unit circle. Okay, so it's on the terminal arm of angle theta in standard position. Draw a diagram to represent this situation. So basically, I want to draw this point on our diagram. So let's draw our x and y axis. Okay, let me do this as best I can. We have the point. I hope you guys can tell what quadrant it is. Since x is positive and y is negative, you have something in the fourth quadrant, right? So you have this point here, put the point, so 5/13, negative 12/13. So that's basically our point. It's on the terminal arm. So, sorry, the diagram's not great. Let's see if I can do a little bit better job here, sorry. Okay, so we're going to have this line here, and then our point will be right here. Okay, so draw a diagram represents the situation. That's where the point is. Okay, everything's good. Okay, so now find all 6 trigonometric ratios for theta. So again, we're going to have this triangle here, right? So this is our triangle that we can create, and this is the angle theta right over here. Okay, so since this point, maybe I'll put the coordinates. This is 5/13 and negative 12/13. Okay. You would first need to find the value of this right here, of the hypotenuse. So hypotenuse is pretty easy to figure out. It's just 5/13 squared, so it's x squared plus y squared equals to r squared. We'll call that the radius, often what we call when you're talking about this circle. Okay, so you expand that, you get 25 over 169. plus 144 over 169 equals to r squared. And if you notice, if you add those together, you get 169 over 169, which is 1, right? Square root of 1 is 1. So all this means is that this point is on the unit circle because the radius is 1. Okay, so if we want to do sine theta, right? Sine theta is opposite over hypotenuse, and the opposite side is negative 12 over 13. Okay, I'm just going to move this so I have a bit more space. Cos theta is adjacent over hypotenuse, so we have 5 over 13. Don't forget the hypotenuse is 1, so when you divide by 1, you just get the exact value of x and y. We're on the unit circle. All right, and before I do a tan and cotan, maybe I'll find the reciprocal function of sine. Well, the reciprocal function, if you remember from last page, that's cosecant theta, and that's 1 over this. So the easiest way to do that would just be to flip that fraction around. So the cosecant value would be negative 13 over 12. Notice that I attached the negative to the numerator just to stay consistent. Okay, it doesn't matter where you attach the negative. And secant theta, so that's supposed to be an e, secant theta, which is the reciprocal of cos, again would be just the reciprocal fraction of this, so it would be 13 over 5. Alright, so tan and cotan a little bit different. So for tan, you basically have to divide sine over cos. So tan theta, so hopefully I can have enough space here, tan theta is equal to sine, which is negative 12 over 13, divided by 5 over 13. Okay? Might go over this in class to make sure we understand how to divide those fractions, but if you simplify that completely, you get tan theta equals to negative 12 over 5. Notice that since the denominators are the same, they just kind of canceled out. And the reciprocal function of tan, which is cotan, is equal to, again, all you got to do is take that fraction and flip it around. Okay? Alright, so that's all the trig ratios for this angle, opposite over adjacent, which is your tan. You have opposite over hypotenuse, which is your sine, and you have adjacent over hypotenuse, which is the cos. Okay, next example. If cos theta equals to negative 1/5, and we are in the fourth quadrant, find all other 5 trigonometric ratios. Alright, so again, I'm going to kind of draw a diagram here, but I'm going to draw this one a little different. So I know I'm in the fourth quadrant, so I'm going to make sure there's room there. And I know that the ratio of cos is adjacent over hypotenuse. So I'm going to use those values as the pieces of my triangle here. So adjacent is 1. So the angle in the fourth quadrant is over here, right? So you're always according to the x-axis. So you have the angle right here. You have adjacent over hypotenuse, okay? And you don't know the y value here, because that would be the y value of your triangle. So the first thing I'm going to do is calculate the y. So you have x squared plus y squared equals to 5 squared. So you have y squared equals to 24, right? So this would be 25, and then 1, and then you bring the 1 over, and you take the square root of y, you get plus or minus square root of 24. But notice that in this case, because we're in the fourth quadrant, your y value is technically negative square root of 24, because again, fourth quadrant. And this gives us all the information we need, so this would be negative square root of 24. This gives us all the information we need to get all the trig ratios. So let's start with sine. Sine theta will be equal to opposite, negative square root of 24, over hypotenuse. So negative square root of 24 over hypotenuse. Tan theta will be equal to opposite over adjacent. So negative square root of 24 over 1, right? So over 1, so I'm not even going to write it. We're going to write the reciprocal function of sine, which is cosecant theta. And again, all we got to do is flip those around. You get negative 5 over square root of 24. The reciprocal function of tan, which is cotan, which is a negative 1 over square root of 24. Right? So again, I kept the negative up top, but you flip this fraction around, it's over 1. Now you have 1 over square root of 24. And the last one we need is the reciprocal function of cos, and that's just flipping this fraction around. So you'd have negative 5 over 1. Okay, that's it for that. Okay, in this example, it's determine the exact value of the following trigonometric ratios. So this all comes from your unit circle. So if you have your unit circle handy, probably a good idea. Yeah, all of a sudden you're going to see appear a unit circle over here. Okay, so here, for the cos value of pi over 3, so first you got to do is you find your pi over 3 on your unit circle, and cos is always the x value. So at the point pi over 3, the x value is a half, so that means cos of pi over 3 is 1/2. You can test that by throwing that in your calculator. You'll get 0.5. Okay, so secant of pi over 3 kind of works the same idea as what we just did. This is the reciprocal value of cos. So if cos of pi over 3 is 1/2, secant of pi over 3 is just the reciprocal of that value. So simply, it would be 2 over 1, right? So compare those two. So cos of pi over 3, secant pi over 3, you don't reciprocate the pi over 3, it's still pi over 3. You reciprocate the value of the function. Okay, so let's do a few more. I'm just going to move this over so we can kind of see other ones. Here, for sine of negative 5 pi over 6, the easiest way to do that would be just basically finding an angle that's on your in your first revolution of positive values. So instead of using negative pi over 6, I'm going to say, well, I'm going to add 2 pi to that. Right? If you remember coterminal angles. So that would be 7 pi over 6. So that means that sine of negative 5 pi over 6, sorry, would be equal to sine of 7 pi over 6. And sine of 7 pi over 6, you bring this back again. 7 pi over 6 is over here, right? And your y value, because we're talking about sine now, your y value is negative 1/2. So that's what we do. We say this is negative 1/2. Oops, sorry about that. Okay, next thing, cos of 7 pi over 4. I'm hoping you have your unit circle now, so I'm just going to kind of use these values. You can kind of check. Maybe I'll move this here. 7 pi over 4 is over here on the unit circle, and the cos value is square root of 2 over 2. Okay. Cotangent of 270 degrees, so 270 degrees is over here. Cotangent, if you remember, is x over y. So in this case, it'd be x over y, which is 0. Okay. Cosecant of 2 pi over 3. 2 pi over 3 is over here on the unit circle. And this is the reciprocal of sine. So the sine value is square root of 3 over 2, which is your y value, right? So what you do is you flip that, you have 2 over square root of 3. Okay, we'll keep going. Tan of 11 pi over 4, again, not a value that's in your first rotation. So what you probably want to do is take your 11 pi over 4, subtract 2 pi, so get into your first revolution. Sorry, this shouldn't be a 4. Sorry, 2 should be a 4. And you get 3 pi over 4. So this would be equal to tan of 3 pi over 4. And now 3 pi over 4, that's found right over here. Tan is y over x. So if you look at it, you have negative square root of 2 over 2. Over 2. Divided by negative square root of 2 over 2. Sorry, that would be positive because the x... sorry, I'm going to start that again. So the y, which is square root of 2 over 2, it's positive. And then the x is negative square root of 2 over 2. Notice that these are two the same values, so this would just be equal to negative 1. And last but not least, 5 pi. So 5 pi, again, you're not a value in your first unit circle, or first revolution. So we're going to take 5 pi. we're going to subtract 2 pi, which is going to give us 3 pi. That's still not in the first revolution. So we're going to take 3 pi, subtract 2 pi, we get pi. So the secant value will be the same as the secant value of pi. Well, what's pi? Pi is over here. Again, you're working with your unit circle. Pi is over here. The cos value is -1, because that's the x. So you flip it. So you go -1/1. Notice it's still -1. So the value of secant and cosecant, and cosine are the same at that point. Alright, so nice last little note here. It is easier to find coterminal angle in interval 0 to 2 pi than is to find the appropriate value according to the trig ratio. So exactly like I did here, instead of working with 11 pi over 4, I'm changing it to 3 pi over 4. Instead of working with 5 pi over here, I'm changing it to pi. So work with the first values in your unit circle. Okay, so in this last example, all we're doing is doing the exact same thing, except that we are taking those values and adding them or subtracting them, or in this case multiplying them together. Okay, so again on the unit circle, have your unit circle handy to follow this, please. Cos of 120 degrees. 120 degrees at the same spot is 2 pi over 3, and the cos value there is -1/2. So this is -1/2. We subtract, right? That's the subtraction. And tan of -135 degrees, and that, if you take -135 is over here, the tan value over there is 1. So you have -1/2 minus 1, which is -3/2. Alright, so here, notice that the sine and the cos value are squared. So now we have sine of 7 pi over 6 squared. This would be the same thing as saying this. So this is sine of 7 pi over 6, all that squared, plus bracket cos 7 pi over 6 squared. So this would be the same as this. These are the same expressions. So the value of sine of 7 pi over 6, again, find that on your unit circle, is -1/2 squared, and the cos is square root of 3 over 2, negative squared. So this would be 1/4 plus 3/4, which gives you 1. This comes back to the idea, if you have the same angle, and you have sine squared plus cos squared, you should always equal to 1. Okay, so the last two, again, find these values on your unit circle. -3 pi over 4 is the same spot as 5 pi over 4, and the cotan value is 1, because the tan value is also 1. Cosecant, okay, so this, you're looking for the sine at pi over 2, okay, and the sine at pi over 2 is 1, and 1/1 is 1, because you have to reciprocate it. Okay, so the last one here, tan of -pi over 3, so again, find that value of -pi over 3, that's over here, so it would be the same spot as, hope you can figure that out, this is the same spot as 5 pi over 3. And tan of 5 pi over 3 is square root of 3. Sorry, negative. But that won't matter, right? Because of the square. So it's negative square root of 3 squared. And secant of 4 pi over 3. Again, looking at your unit circle, 4 pi over 3, you're looking for the value of cos. The value of cos is -1/2. So when you flip it, you get -2. So what you have is 3 times -2. And you have -6. Okay, good luck, guys. I'm sure we'll talk about these questions and maybe a couple others in class.